Hello AP Chemistry and welcome to section 15.5, calculating K. So first of all, going back to what K is, right? When we talk about our K expression, we are talking about products raised to their respective coefficients over the reactants concentrations raised to their respective coefficients. Now, do be mindful when we talk about concentration, right? We do mean molarity, right? We can also mean atmospheres, right? Because atmospheres, again, going back to what molarity is, right? Atmospheres are directly related to moles, right? Which, again, are the amount of whatever we're talking about, right? So molarity or atmospheres are the most common things to put in here. Do be mindful, moles, not one of the things we put in here, right? Because what we're going to really talk about for our rice tables, we can use moles in the rice table, but we have to make sure that molarities are what actually goes into our K expressions. All right. So let's go ahead and do a practice exercise together. So, okay, obviously we skipped one, but obviously this is an equilibrium expression. These are equilibrium concentrations. Yes, equilibrium expression requires equilibrium concentrations, which means that the first practice problem, for example, really easy because it tells you the equilibrium concentrations. You plug it in, raised to their respective coefficients. Now, slightly more thoughtful, right? Says we have sulfur trioxide decomposes at a high temperature in a sealed vessel, right? So let's go ahead and start by writing our reaction, which says 2SO3, 2SO2 plus O2, right? And they're all gaseous. And it says that initially the vessel is charged at 1000 Kelvin with SO3 at a partial pressure of 0.5. So I know that this is 0.5 atmospheres. And I have my change and my equilibrium. Okay, now, so if initially I'm charged with just this, right, that means I have how much of these? Obviously that much, right? Now, it says that at equilibrium, the SO3 partial pressure is 0.2, right? Note that that's not a change. That's my equilibrium partial pressure of SO3 is 0.2 atmospheres, right? And I want to know my Kp. Now, so now we need to figure out what my changes are, and change is always going to be based on stoichiometry, right? So I know that this says 2 of these, right? So that means I'm going to lose 2 of those, right? Because that's what's in my vessel, that's what's going to be consumed. These are going to be produced at a rate of 2x and x, yes? Which means that this equilibrium concentration is going to be equal to 2x, this one's going to be equal to x, and this one is 0.2. Now, if I look here, right, if I look at all of this, can I solve for x? Right. So what I'm going to do is I'm going to solve for x here, and then I'm going to plug that x in here, and then once I have all of these, I'll plug that into my equilibrium expression, right, in order to solve for Kp. Yes? Fantastic. All right. Thank you for listening. Be good, and I will see you soon. Bye.